Welcome to Brno University of Technology, Faculty of Mechanical Engineering, which is a home base for Chicken Wing Student Team. Chicken Wing Student Team was established in 2014 with aim to participate in Air Cargo Challenge 2015 held in Stuttgart. Since then, we participated in 6 different international competitions. This year, Air Cargo Challenge competition aim is to design an electrically powered UAV with capability to transport a maximum payload amount while flying as fast as possible for 2 minutes flight time. 100-meter climb, payload mass and flight distance have the strongest influence on final score. The size of assembled flight-ready aircraft must fit into a rhombus-shaped box with an edge length of 1.5 meter each. It's the airplane placement in the ready-to-flight box that influences the entire conceptual model design. Selected wing position allows enough wingspan and provides enough space in the backward for the tail unit and in the front for the engine.
For the wing, the elliptical wing was chosen since it's the most efficient design and provides the lowest induced drag. The low induced drag enables reaching the best possible aspect ratio. The wing area of the model is 0.5 meters squared, with a wingspan of 2,200 millimeters. Aspect ratio is 9.66 and root airfoil length is 290 millimeters. The key aspects of wing performance are efficiency and gliding properties. Both have a large impact on overall competition evaluation. It is therefore vital to find a wing airfoil with gliding ratio as high as possible. 2 airfoils were used due to necessity of aerodynamic twist of the wing. High-lift system is very beneficial not only for general aviation aircraft, but for UAVs as well. By adding the mechanism to the wing, it is possible to influence the lift coefficient, hence the takeoff distance and performance characteristics. From all the considered possibilities, the V-tail was chosen because of its lightweight construction and lower induced drag. Better stability is caused by 2 divided areas of the tail. The total tail area of the design tail is 0.11 meters squared and the tail span is 720 millimeters. The symmetrical profile NACA 0010 was chosen for the tail surfaces. The symmetrical airfoil is characterized by the same aerodynamic properties for the positive and negative angle of attack. Main parameter for the airfoil selection is low value of drag coefficient. The fuselage was divided into 2 parts, so it can easily fit into the transportation box. In the front and middle parts, which are connected, all the necessary electronics and paying loads are stored. The rear part serves to connect the tail surfaces with the front of the fuselage. Based on the knowledge of the cargo bay dimensions, it was possible to create the geometry of the nacelle and the entire middle part of the fuselage. The effort was to keep the external dimensions as small as possible, given the already sizable cargo. Fixed tricycle landing gear was chosen with better handling characteristics, low weight with sufficient strength, and good static and dynamic stability.
From the flight performance analysis, to achieve required climb speed and takeoff distance, the maximum takeoff weight was determined to 5,000 grams. From the weight analysis, the aircraft empty weight was calculated about 2,900 grams. Then the expected maximum weight of the payload is 2,100 grams. Payloads are packages of artificial blood of 1, 2 and 300 grams. So the requirement is that the load should primarily consist of the heaviest 300 gram packages. A combination of 7 packages of 300 gram was chosen as maximum payload. Other configurations are possible, but the center of gravity position stays unchanged for all payload configurations. It was decided to shelve the payload in the vertical position. This decision was made because of the liquid nature of the blood packages. Storing blood bags in this way prevents an overflow and minimizes the liquid movement in the airplane. This position is considered to be the safest option for flight.
The competition does not restrict the use of any materials. The design of the structure takes into account that the model must be disassembled and that all its parts fit into transportation box. In aircraft construction, multiple materials are used: carbon and glass fabrics, plywood and balsa wood, aluminium alloys and PLA plastics. With the help of laser cutting technology, we are able to achieve precise shapes and profiles, such as ribs, in a very short time from any kind of wood. The ribs form the basic transverse support system. The basic task of these elements includes securing the required shape, capturing some partial loads, separating the interior spaces, and reinforcing the edges. To keep the structure firm, strong and light enough, proper material selection is a vital aspect. Due to its complexity, the carbon fiber composite and glass fiber composite were chosen as the best materials for the D-box and fuselage structure. It has high strength, low weight. However, the most important characteristics is good formability during manufacturing. Molds are made from MFD wood. After milling process, the molds need to be grinded to achieve desired surface quality. The hand lamination is used for every laminated part. The wet lay method, carbon fiber cloth is added to the mold, one layer at a time, and each layer is wetted out with resin by hand using a brush or a roller. D-box surface is made as combination of carbon fiber and Rohacell foam core. The fuselage is made from glass fiber layers. For parts of a more complex shapes and some prototypes, 3D printing was decided to be used, as it is cheap and simple method to produce complex shapes. The possibility of changing the inner structure also leads to a huge weight reduction by topological optimization. Winglets and some connectors and stiffeners are examples of parts that were made by this technology.
Meet the new model, the Black Swan, with 2.2 meters wingspan, maximum take-home weight of 5 kilograms, possibility to carry up to 2 kilograms payload in the form of blood bags, is the smallest model of Chicken Wing student team.